Good morning, everyone. This is lecture number 5, and we are in motion in one dimension. Do you remember what we were doing in the last class? Yes.
Yes, sir. We were doing types of acceleration. It's done, and we were doing important notes.
Yes, we were dealing with acceleration. We had seen the various types of acceleration, instantaneous acceleration, average acceleration, uniform acceleration, non-uniform acceleration, and so on. So in today's class, we'll go ahead. Now, before going ahead, let us deal with a problem. Remember, uh, what we have done till now, it is not restricted to 1D motion. We have done the definition of accelerations, we have done the definition of velocities and so on, which are valid in all dimensions, right? So yeah, these are definitions. I told you that, yes or no,
Yes, sir.
right? So having said that, why don't we try a problem and understand that whatever we have done is valid for all types of cases. And this is the problem that I'm going to put for you. I hope you can see this. So the problem goes like this: position vector of a particle varies with time according to the law. Now, what type of motion is this, bacha? What type of motion is this? You can see the position vector of the particle varying with time in this particular fashion. What type of motion is this? Is this motion in 1D, 2D, or 3D? Tell me. Is this motion in one dimension, two dimension, or three dimension? The position vector of the particle varies like this. Motion in 1D, 2D, or 3D? Tell me. You can just you can just write it in the chat if you don't want to speak. Yes, Anjali. It is motion in 3 dimension because the particle has x, y, and z, all the 3 coordinates. R is in meters, t is in seconds. Find a suitable expression for its velocity and acceleration. So you have to find the velocity and acceleration of the particle as a function of time. Then you have to find in part 2 the displacement, the magnitude of displacement, and the distance traveled. Remember, whenever a question comes of distance traveled, it is the most difficult question because to find out the distance traveled, we need to find out how the particle has moved. Do we understand this? Yes or no? You can just raise your the thumb in the chat, and I will be able to understand that you have understood. So whenever someone asks you to find out distance, it is the most difficult question because that question will involve a lot of things. Anjali, Chandrika, Kaushik, Karthik, Shret, do we understand this? Everyone. So I'll give you 5 minutes to solve this question. And once you are done, please let me know. I hope everyone is trying. Yes, anyone got any answer? Three more time, right? Anjali, Chandrika, Kaushik, everyone is trying the question, right?
Yes, sir.
Okay, so give you time. I want you to do it. Do you need any help? Shall I help you? Or you will be able to solve it better? Need any help? Okay. Seems like everyone is trying. I'll give you time. 2 more minutes. Okay. I think I should help you now. Right? Anyone has tried? Raise your hands so that I will know that everyone has tried. Kaushik has done. Anjali, Akhilesh. Anjali has not tried. Chandrika, Shrihit. Everyone has tried. Okay, you must have got some answers, right? Let us check how we are supposed to do this. Okay. Tell me, anyone. You can unmute yourself. I hope you can. Tell me what is the first step. How do I solve this? What is the first step? Tell me the first step. I am given r vector. Position vector is a function of time. It is t squared by 2 I hat minus 4 by 3 t raised to the power 1.5. Now it is given in this way for a particular reason. And once we solve the entire question, you will understand why it is 1.5. Just have some faith. Plus 2 times t k. Yes, what is the next step? I have written r, which I don't need to write. Remember, you are solving this question in an examination hall and you are not supposed to write this step, because the more the steps you write, the more that time you consume in the examination hall, and you don't have time to consume there. Tell me, how do I do the first thing? Find out the expression for velocity. How do I get velocity? Tell me fatapat. How do I get velocity from here? V vector.
Differentiate.
It is a derivative of this thing with respect to time. I hope you know how to differentiate it. Yes or no?
Yes, sir.
So you will get something like this. Ti, the derivative of t square by 2 is t multiplied by I, minus, I think you will get 2 root 2t j hat. Yes or no?
Yes, sir.
Plus 2 k hat. This is the expression for velocity. Which type of what velocity is this? Is this average velocity? Is this instantaneous velocity? What? I've got this velocity, my dear friends. Whatever I am highlighting in yellow, what type of, velocity is this? First of all, tell me, is it uniform or is it non-uniform? Is the velocity uniform or is it non-uniform? Tell me fatafat. Is this uniform velocity or is it non-uniform velocity? Yes? No one knows it. Is it uniform velocity or is it non-uniform? A simple question, bacha. It is non-uniform velocity, Shruti. Yeah, that is absolutely correct. This has to be a non-uniform velocity. We all understand this, yes or no?
Yes, sir.
That this
Yes,
is
sir.
non-uniform velocity. Now, just to add further to our discussion, this velocity has 3 components. This is the first component, this is the second component, and this is the third component. This first component is the velocity ka x component, yes or no?
Yes, sir.
You understand this? This is velocity ka x component. The second one is velocity ka y component, and the third
component.
one is velocity ka z component. Now, talking in terms of component, you can look at the component and tell me which component of velocity are uniform velocities and which component of velocities are non-uniform velocities. Yes. Overall, if I talk about this velocity, it is definitely a non-uniform velocity. But if I break it into components, component-wise, can you tell me which component of velocity is uniform and which component of velocity is non-uniform? Yes. Which component of velocity is uniform and which component of velocity is non-uniform? Shruti, do we understand this? Velocity
Yes.
varies as a function of time, so it cannot be uniform. Now, which component of velocity is uniform and which component of the velocity is non-uniform? Tell me fatafat. Quickly. Shrihit, Shruti, Kartik, Kaushik, Chandrika, Anjali. Which component of velocity is uniform? Which component of velocity is non-uniform? Tell me. Yes? We don't understand this? Looking at the x component of velocity. This is the x component of velocity. Is it uniform or is it non-uniform? Tell me fast. X component is uniform, Karthik. How did you get uniform? It is a function of t. You can see a t there. So this component of velocity is non-uniform. Do we understand this?
Oh, yes, sir.
Please, all of you raise hands that we understand this. This component of velocity is non-uniform. Raise your hands and let me know. Okay. What about the y component of velocity? Look at the y component of velocity. Tell me whether it is uniform velocity in y axis or is it non-uniform?
Non-uniform.
It
Non-uniform,
is
sir.
also non-uniform. Now look at the z component of velocity and tell me whether
Mm,
the z component of velocity is uniform or non-uniform.
It's uniform, sir.
Yes, so velocity has got three components. Along x and y, the velocity is non-uniform. Along the z-axis, the velocity is uniform. Do we understand this? Please raise your hands.
Yes, sir.
Is it clear to everyone?
Yes, sir.
Now, from this discussion, we can also understand along which axis we will have acceleration. Now, look at the velocity. Do not differentiate it now. And looking at the velocity, now you can tell me along which axis the particle is accelerated. It is accelerated along x. Is it accelerated along y? Is it accelerated along z? Along which axis is the particle accelerated? Tell me. Along which axis will the particle be accelerated? The x and the y component is non-uniform, but the z component is uniform. So you will have acceleration along which axis?
Along Z.
We will have acceleration along z. If the velocity is uniform, then we have acceleration. Is that so? What does acceleration do? What does acceleration do? Okay. Let us differentiate this velocity. Velocity is the derivative of, let us differentiate this velocity and get the acceleration. Acceleration is the derivative of velocity. What will be the acceleration coming like? Tell me. Differentiate it. Do it fast. What is the acceleration coming like?
Minus t.
Huh?
Minus t, sir.
Acceleration is coming minus t. How have you differentiated it? No, will not come minus t. It will come I. Derivative of t is 1. dt by dt. I minus 1 by root tj. This is the acceleration that you will get. Yes or no? I've just differentiated. I've just differentiated equation number 1. I've just differentiated equation number 1. Do we understand this? Yes or no? I have just differentiated equation number 1 and I land up with this equation number 2, which gives me the acceleration. Do we understand this? The blue equation. This is the equation of acceleration. Yes or no?
Yes, sir.
Now you can understand. This acceleration has two components. This is the acceleration ka x component and this is the acceleration ka y component. The particle has acceleration along two axes, x-axis and y-axis, and therefore the velocity along x and y was non-uniform. It does not have any acceleration along z-axis, and therefore the velocity along z-axis was uniform. Do we understand this? This velocity is uniform, which implies acceleration along acceleration along z-axis is 0. Do we understand this? Raise hand will give me more confidence that we have understood this. Anyone has any doubts, please raise your hands. I guess no one has doubt. Yes or no? Do we understand this? So this is the acceleration. Now, this is the acceleration in vector form. You can also find the magnitude of this acceleration. The magnitude of this acceleration, I can simply write it as A. Can you tell me what is the magnitude of this acceleration? How will I find the magnitude of this acceleration? It will be x component ka square plus y component ka square. So that will be equal to 1 square plus, tell me, 1 square plus
1 by root t whole square.
1 by 1 by root t ka square, right? 1 by root t ka
Yes, sir.
square is 1 by t. Do we understand this?
T. Yes, sir.
So this is how you can find out the magnitude of acceleration. Now, talking about acceleration, is this acceleration uniform or is this acceleration non-uniform? Look at the acceleration, look at the blue part. Is this acceleration uniform or is this acceleration non-uniform?
Non-uniform, sir.
Look at the component of acceleration, x component and y component. Which component is uniform and which component is non-uniform and which component is zero? Which component is uniform? Look at acceleration along x. It is uniform
X
or
is uniform, sir. Y is non-uniform and K component is 0.
x is uniform, y is non-uniform, and the z component is 0. Do we all understand this?
Yes, sir.
Okay, we have found out the magnitude of acceleration. That also asks us to find out the magnitude of velocity. Can you find out the magnitude of velocity? Can you find out the magnitude of velocity? Magnitude of velocity, I can simply write it as v. What is the magnitude of velocity, my dear friends? Magnitude of velocity, it has 3 components, x, y, and z. Acceleration had 2 components, x and y. But you can easily find out the magnitude of velocity. Tell me, bacha, what is the magnitude of velocity? Remember, this is instantaneous velocity. Velocity as a function of time. It is instantaneous velocity here. Yes. Tell me. What is the magnitude of velocity? I hope you know how to find it out. Yes or no? It will be under root of t square plus 4t plus 4. Do we
4.
understand this? Yes or no?
Yes, sir.
How did I get it? X square plus y square plus z square. Do you all understand this? Please raise your hands and let me know. Everyone understands this? Okay. Now, you can write this magnitude of velocity t square plus 4t plus 4 ka root. This is t plus 2 ka whole square. So, okay, you can simply write it as t plus 2 root over t plus 2 ka whole square is t plus 2. Yes or no?
Yes, sir.
All of us understand this magnitude of velocity. Yes or no? Please raise your hands. Magnitude of velocity is t plus 2. Okay. Now, if you remember, this is instantaneous velocity. We have found out the magnitude of instantaneous velocity. We call this magnitude by a different name also. The magnitude of instantaneous velocity. So what I can call this magnitude of instantaneous velocity? We have discussed this. What is the magnitude of this instantaneous velocity known as? Tell me. What is the magnitude of this instantaneous velocity known as? This thing that we have found out is instantaneous what? This is instantaneous speed. Do we understand this?
Yes, sir.
Magnitude of instantaneous velocity is instantaneous speed. All of us understand this, yes or no? I only have two raised hands. Do we all understand this? Magnitude of instantaneous velocity is instantaneous speed. Now let us move and find the next thing. What was the next thing? We had to find out the displacement of the particle from 0 to 4 seconds. Yes or no? We had to find out the displacement of the particle r delta r vector from 0 to 4 seconds. So how will I find this displacement first? To find out the displacement first, I have to find the position of the particle at the final point, 4 seconds, minus the position of the particle at 0 seconds. Yes or no? Final position minus initial position. Do we understand this?
Yes, sir.
At initial position, when you put the value of t as 0, the position is 0, so that is 0. Now just put the value of t as 4 and you will get the displacement from 0 to 4 seconds. Can you tell me what is the displacement from 0 to 4 seconds? Just put the value of t as 4. You will get the position at 4 seconds. The position at 0 seconds is 0 origin. Therefore, the position at 4 seconds is the displacement. Yes or no? What is the displacement we are getting? Can I have your answers? I'm waiting. Anyone got the answer? Is it so difficult? In this red equation, you just need to put the value of time as 4 seconds. You can do that, yes or no? You can do that, yes or no? Yes, so tell me the answer, beta. The answer that you will get would be, I think, 8i minus 32 by 3j plus 8k. Are we getting this answer, everyone?
Yes, sir.
Why don't you speak up, beta? We got this answer? Once we get this answer, it is easier for us to find the magnitude of displacement. To write the magnitude of displacement, I just use delta r. The magnitude of displacement will be root over 8 square plus 32 by 3 ka whole square plus again 8 square. So you can calculate this and just write it like this: 8 square plus 32 by 3 whole square plus 8 square, and you can get your answer. I'm not worried about this. The last thing that I'm worried about is to find L. L, which is the distance traveled. How will you get the distance traveled by the particle? How you will get the distance traveled by the particle? How will you get the distance traveled by the particle? Anyone? Anyone knows the answer? How would you get the distance traveled by the particle? No one knows it? Okay. No one knows it? Okay. We'll come back to this question. We will come back to this question after some time. So leave some space here. And I'm leaving some space here. And we will move at S is equal to U plus AT. I don't know, Shrihit, what you are talking about. I really don't know what you are talking about. Okay. We will try when we come back again. Let me frame one question for you. And I hope you can see my screen. Question number 2. Let me do it this way. Let us, before putting the question, let us understand what we have understood till now. We have understood that, and you can write it as important note, dr by dt is v. dr is the small change in position. dr by dt is v. We all understand this, yes or no? We have written the definition of velocity. Rate of change of position vector, dr by dt is v. Now I can write this equation in this fashion. I can write dr, small change in position, will be equal to v dt. Yes or no? Small change in position will be equal to v dt. If I put now integration on both sides, small change in position is dr. Integration of dr will give me the displacement, or if I write it from position r1 to position r2, on this side I will get final position r2 minus initial position r1 would be equal to integral of v dt. Do we understand this? Yes or no?
Yes, sir.
And final position vector minus initial position vector, that would give me the displacement vector.
Displacement.
So displacement vector would be integral of v dt. Do we all understand this? So to get displacement from velocity, we need to integrate it. Yes or no? We all understand this?
Yes, sir.
I am not getting raised hands from everyone. To get displacement from velocity, we need to integrate it. Okay, let me take the next step here then. What would be the next step? The next step would be like this. Derivative of velocity with respect to time. And remember, I'm writing vector equations, so they are valid for all types of motion. dv by dt is a. From this equation, I can write dv vector. So basically this dt goes here. I hope everyone understands this. dv vector will be equal to a times dt. If I put integral on this, integral of dv would be v, and I put the limits from v1 vector to v2 vector. On the left hand side, I will get v2 vector final velocity minus v1
initial
vector
velocity.
initial velocity will be integral of a dt from time 0 to t or from time t1 to t2. Do we understand this? Yes or no? No or yes?
Yes, sir.
I'm not getting raised hand and from everyone in the class. That makes me worried that we are not on the same page. Do we understand this, everyone? Okay. Now, having said this, let us now. I hope everyone has written this. Yes or no? Okay. Now, having said this, this is the question that I'm going to frame for you. I hope you have noted it down. So, the velocity is given as 2t I minus t square j plus 2k. At time t is equal to 0, the particle position is 0. Find A. I hope you understand what is the meaning of A and R vector as a function of time. I hope you understand the meaning of the question. A stands for what?
Acceleration.
And R vector stands for what?
Position vector.
Okay. You are given velocities as a function of time. The first question is, and I will make more questions in this one so that whatever we have read till now gets covered. Find A vector and R vector as a function of time. This is your first task. You will get 2 minutes to solve it. And I hope you will not disappoint me this time. And you should be able to get an answer. Remember, getting an answer is not important. Trying the question is more important from where I see. Try. 2 minutes. Yes, Bacha, do we have any answer? No one? Do you need more time, Bacha? Tell me, beta. Are you all trying?
Yes, sir.
Okay. One more minute. Acceleration is Ti cap minus 2Tj cap. Something you have mistaken, beta. Try it again. I'm sure you can do it. The simple derivative. To find out the acceleration, you just have to find out the first derivative of velocity. And the first derivative of velocity, you just need to differentiate the first equation and you will get 2I minus 2Tj. Do we all understand this? Everyone? Derivative of 2t is 2. Derivative of t square is 2t with a minus sign. So this is the acceleration of the particle as a function of time. Do we understand this? Now to find out the position vector of the particle as a function of time, dr vector, the integral is equal to v dt. Yes or no? Now we integrate this dr vector. Initial position is 0. Do we understand this? So I put the lower limit as 0 and the upper limit as r vector. Do we understand this? Yes or no?
Yes,
Okay,
sir.
Shruti. I mean, you wrote T in the answer. That is why I asked you this. 0 to r vector is the limit of dr vector. Time is 0 to t. So I'll put the limit of time from 0 to t. Do we understand this? How I put the limits? So on the left hand side, the integral of dr is capital dr is r. I put the limit from 0 to r. On the left hand side, my dear friends, I will get r vector. Do we understand this? Yes or no? On the right hand side, I just need to integrate this. So I will just write integral from 0 to t, integral from 0 to t of 2t I minus t square j plus 2 times k, the entire thing multiplied by dt, and I need to just integrate this and get the value of r vector as a function of time. Remember, you will have to put the limits. The initial limit is 0, then the final limit is t. What is the answer that you are getting? I think the answer that you will get would be t square minus t cube by 3 plus 2t. After integration, this is the answer that you should get. And this is the position of the particle as a function of time. Do we understand this? Yes or no?
Yes, sir.
Everyone got this answer? Yes or no?
Yes, sir.
Now I can ask you a variety of questions here. For example, the first question that I am going to frame now, after this, let us say this is question number 2. Find V dabba. Why I'm not able to make a dabba? Find V dabba and A dabba from 0 to 1 second. Can you find out the values of these two dabbas from 0 to 1 seconds? Can you find out the value of these two dabbas from 0 to 1 second? I'll give you time to do this. Can you find the value of these two dabbas from 0 to 1 second? I hope you understand the question that we are doing. Yes or no? No, yes. What we have achieved, what we have found out here is the instantaneous acceleration, instantaneous velocity, and instantaneous position. Position as a function of time. What I'm now asking you is to find out the average value of velocity and average value of acceleration from 0 to 1 second, and I'll give you 2 minutes to solve this. Do we all get this, my dear friends? I think I have made a mistake here in writing. I have not written I, J, and K here. Small mistake, but it makes a hell lot of a difference in solving the problem. Yes, beta. Anyone got any answer? To find out average velocity, what do we need to find out is total displacement and divided by total time. Yes or no? Total displacement means we have to find out displacement at 1 second, subtract it, displacement of 0 seconds, and divided by total time, which is 1 second. Do we understand this? Yes or no? To find out displacement at 0 seconds, we have to put the value in this yellow equation of time as 0. If you put the value of time as 0, you will get displacement as 0 because it is already given. Displacement at 0 seconds is 0. Do we understand this? To find out the displacement at 1 second, you have to put the value of time here as 1. Do we understand this?
Yes, sir.
Just put the value of time as 1 and you will get your average velocity. What is the average velocity that you are getting? So put t as 1. So I minus 1 by 3j plus 2k divided by 1 remains same. Answer is I minus j by 3 plus 2k. Do we understand this? Yes or no? It's not 8 by 3 beta. It has I, j and k components. Do we understand it? It is not 8 by 3, and that is a mistake that I made. I forgot to write I, j and k. It has got 3 components. I cannot add or subtract those components because they are along different axes. Do we understand this? So it is I minus 1 by 3j plus 2k. Remember, this is a question of 3-dimensional motion. Do we understand this? Raise hands will give me more confidence that we understand this. Now, can you find out the average acceleration from 0 to 1 second? To find out average acceleration, you have to find out change in velocity and divide it by time. When I talk about change in velocity, final velocity at 1 second minus velocity at 0 seconds divided by time is 1 second. So what you got to do is, in the formula for velocity, put time as 0. In the formula of velocity, put time as 1 and you will get your answers. Do we understand this? Yes or no? Can you tell me what is the average acceleration, dear? To put the value of time as 0, to put the value of time as 1, then subtract. I think the answer that you will get is 2i minus j divided by 1. So the answer would be 2i minus j. This is the average acceleration from 0 to 1 seconds. Do we understand this? Yes or no? Can I have raised hands from everyone that we understand this? Only 3 people have understood this. What about the others? So remember, when you get acceleration as a function of time, that is your instantaneous value. When you get velocity as a function of time, that is your instantaneous value. To find out the average value, you will have to use the definition. Average velocity is total displacement divided by total time. Average acceleration is total change in velocity divided by total time. Do we understand this? Yes or no? Now again, the question comes, and it is a question that started this entire conversation. How do I find out the speed? Oh, how do I find out the speed? You have velocity. You can find out the magnitude of that velocity. That will give you speed. Instantaneous speed I am talking about. The question that we were trying to answer is, how do you find out distance traveled by a particle? Because that is the most difficult question in any situation, because to find out the distance, we have to know what path the particle is following. How do I find out speed, or how do I find out the distance traveled? To find out speed, Just find out the magnitude of velocity. How do I find the distance traveled from there? Now remember, to find out the distance traveled, there's only one way that you can do this. And I will just give it as a note. Now remember, when I talked about speed and I called speed as S, I wrote speed as dl by dt. This was instantaneous speed, rate of change of distance with time. Yes or no? Do we understand this? Do we remember this? Speed, S, dl by dt, I wrote it. I did not use v for speed because I thought I told you that v gives me the notion of velocity. Therefore, I used s for speed. From here, I can write dl, the small distance, is s speed multiplied by dt. To find out the total distance traveled, there's only one way, and that way is to find out the speed of the particle. You find out the speed of the particle. You find out the speed of the particle and then integrate it. How do you find out the instantaneous speed of the particle? This instantaneous speed of the particle is nothing but the magnitude of instantaneous velocity, or you can call it v without the vector sign. That is why this v is used for speed. V without the vector sign means it is the magnitude of speed. It is the magnitude of velocity, and that magnitude of velocity is known as speed. Do we understand this? Yes or no? No, yes. Everyone understands this? Okay. This is how you can find out the distance traveled. Now let me go back to the question where it all started. This was the question that we were dealing with, and we had to find out the distance traveled by this particle. Now, to find out the distance traveled by this particle, we need to know the speed or the instantaneous speed. And we had already calculated the instantaneous speed. It was t by 2. Do you see this? Yes or no? That was the reason we had calculated instantaneous speed. And that was the reason that this question had t raised to the power 1.5 and all those terms, because they wanted to make this speed come in a very nice fashion as t plus 2. That was the reason that this question had 1.5 in the equation for position. Do we understand this? Speed is t plus 2. Now, with this information and whatever you have learned, can you now calculate the distance traveled by this particle from 0 to 4 seconds? Distance traveled by this particle from 0 to 4 seconds. Can you tell me that? I'll give you 1 minute to do it. Yes, anyone got any answer now? How do I get the distance traveled? Just bacha, tell me. So dl by dt is speed. That implies small distance dl will be equal to s dt. To find out the total distance L, that will be integral of speed dt. Speed we had found out was
T plus 2.
t plus 2. Yes or no? So t plus 2 dt, we just need to integrate this from 0 to 4 seconds and you will have this answer. What is the integral of t plus 2? It is t square by 2.
2.
I put the limit from 0 to 4 plus 2 times t. I put the limit from 0 to 4. Once you put that limit, you will get the answer. Do we understand this, everyone? Can I have raised hands from everyone that we understand this? Anjali, Shruti, Shrihit, do we understand this, bacha? That is how we are supposed to do this. Remember, the questions that we have done were questions of all types, and we had done questions of 3 dimensions straight away. We started, the name of the chapter was motion in 1D, but the questions that we are doing are motion of 2D, 3D, uniform, non-uniform, all types of acceleration. Do we understand this? Yes or no? Now coming back to motion in 1D, I will give you a question of motion in 1D and then we will move ahead. Remember, the questions that we are doing are very general. They may have uniform acceleration, they may have non-uniform acceleration. I hope you understand this. Yes or no? So now I will give you one question which is strictly for motion in 1 dimension. A particle moving along x-axis. So that makes the motion 1 dimension has v. Whenever I use v, it is for velocity. Has v as 2t plus 3. Find x and a as a function of time at t is equal to 0, x is equal to 0. Do we understand the question, everyone? Now remember, this is a question of 1 dimensional motion, 1D motion. Therefore, vectors, position vectors, and these are not asked. It only moves along x-axis, so I only ask you the x coordinate. Do we understand this? Yes or no? This velocity which is given is the velocity ka x component. The acceleration that you are finding is acceleration ka x component, and the position that you are finding is only position along x-axis because this particle is moving only along x-axis. Do we understand this? Yes or no? No or yes? Well then, I'll give you a minute to solve this question. Anyone got any answer, bacha? Shall I solve it for you? Acceleration is correct, Shruti. What about the position of the particle as a function of time? So how do I solve this? Acceleration is dv by dt. Now I'm not using vector sign because this is just motion in 1D. We'll also look at the sign convention. Acceleration is dv by dt. I differentiate velocity 2t plus 3. The derivative is 2. So the acceleration becomes 2 meter per second squared, assuming that everything was in SI units. Is it a constant acceleration or is this a variable acceleration? Uniform acceleration or non-uniform? Tell me. This acceleration does not depend on time, and hence it is a question of uniform acceleration, which we will deal in much detail in the class coming up now. This is the case of uniform acceleration. Do we all understand this? Yes or no? Everyone got this answer? Shruti, Anjali, Chandrika, Kaushik, Shrihit.
Yes, sir.
Then the next thing is to find out the displacement or the position of the particle as a function of time. So dx, integral of dx would be integral of v dt. I've explained it how we have got this. X varies from 0 to x because at time t is equal to 0, x is given as 0 and therefore we have 0 as the lower limit. Time starts from 0, therefore time ka lower limit is also 0. I hope you understand this. And then time ka upper limit is t. On the left hand side, dx ka integral will be x. When I put the limits, x minus 0. Oops, what has happened here? X minus 0. So I will get x on the left hand side, position as a function of time. V dt ka integral is 2t plus 3 dt ka integral. That will be 2t square by 2. So that will be t square plus 3t after putting the limits of the equation. This is the answer that I will get. Do we understand this? Yes or no? Well then, I'll give you a minute. If you have any doubt, you can ask. Else, we will move on ahead with the next thing. And the next thing is we will do a very simple case of motion in one dimension, and that is the case of uniform acceleration. This case we are going to deal in detail. We have dealt with non-uniform acceleration. We will do one or two more problems of non-uniform acceleration. After we are done with this, right now we will concentrate on motion with uniform acceleration. Do we understand this? Anyone having any doubt? Please raise, else we will move on to different cases. Shall we move on, bacha? Shall we move on?
Yes, sir, we can.
Okay, so the first case that we are going to deal with is the simplest possible of them all. Just let me, this is the simplest possible of them all, and that is the case of particle moving with zero acceleration. The acceleration of the particle is zero. Now, what will happen when the particle moves with zero acceleration? Everyone understands this? Yes or no? No, yes. What happens when the particle moves with zero acceleration? Its acceleration is zero, so it will move in the same direction with uniform or constant speed, or I can say the velocity of the particle would be uniform. Yes or no?
Yes, sir.
The velocity of the particle will be uniform. It will be keeping on moving in the same straight line, not turning anywhere, not turning left, not turning right, not coming back. So, in this case, the magnitude of displacement will be equal to the distance traveled. This is the only case when the particle moves with a uniform velocity with zero acceleration. He will keep on moving in the same direction with the same speed, and in this case the magnitude of displacement, because it is in a straight line, and the distance, because the path is also a straight line, will be same. V, the final velocity, will be same as u, the initial velocity. S, I will not write it as s, I will write it as delta r. Delta r means displacement, will be equal to ut plus half at square. So will undergo that equation. Delta r will be equal to ut, and this delta r will be equal to L also, because this is the case where it is moving in the same direction with the same speed. Magnitude of displacement and distance are same. Yes or no? No, yes. Do we understand this?
Yes, sir.
Please note this down. This is case number 1. Particle moving with zero acceleration. Very hardly we will get cases like this. We have done cases like this where the particle was moving with velocity v1 for time t1, then velocity v2 for time t2, and then they asked us to find out the average velocity and all those things, average speed. Those are the only questions which are questions of zero acceleration. Do we remember them? Yes or no? No, yes.
Yes, sir.
That was the only case where you will find zero acceleration. Most of the questions in this chapter are going to come from the case which we are going to do now, which we all know about. What is the second case that we are going to do? Tell me. What is the second case that we are going to do? In first case, acceleration was zero. What is the second case that we are going to do? Which is the most important case? Most of the question in this chapter come from this thing only. Have you noted down the first case? Yes or no?
Done, sir.
Then comes the next case, and the next case is the most widely used case, and that case is on your screens now. That case is known as, everyone knows this, yes or no?
Yes, sir.
What is that case?
Constant acceleration.
That case is the case of constant acceleration. The acceleration of the particle is constant. Now for this case, we will not be deriving any equation. I hope you know all the equation beforehand. Yes or no? You know all these equations? We will just go through those equations in both the scalar and the vector form. Remember, vector wala equations are valid in all the dimensions. The scalar wala equation will be valid axis wise or dimension wise along x axis, along y axis, and we will have to use proper sign convention with them. So these are the equation. I hope. Let us first discuss what do you mean by uniform or constant acceleration. In uniform or constant acceleration, acceleration of the particle will be constant both in magnitude as well as direction. Do we understand this? Yes or no? Please raise your hands that we understand this. Everyone, please raise your hand so that I know that we understand what do you mean by constant acceleration. Acceleration remains constant. We have discussed this many times in magnitude as well as in direction. Well done. Then, now, most of the times we get a question, if the acceleration is constant, is the motion going to be straight line? And I've told you it can be straight line, it can be different. The equation of parabola, or when you throw the particle at an angle, the equation is parabola, the motion is not in a straight line. When will the motion be in a straight line? The motion will only be straight line or one dimensional if the initial velocity and acceleration are either parallel or anti-parallel. So in only that case, the motion is going to be one dimensional. Velocity is like this, acceleration should be like this or like this. Then only it will keep on moving in this dimension. If the acceleration is in any other direction, the motion will not be a straight line. It may be motion in 2D or it may be motion in 3D. Do we understand this? Yes or no? No, yes. This is a question that can come to you as an objective. If the motion is with uniform acceleration, constant acceleration, it is always a straight line. The answer is no. It is only straight line if the initial velocity and acceleration are parallel or anti-parallel. Do we understand this? Yes or no? No, yes. We understand this? Only one people understand this? Not all of you? Anyone having any doubt, please ask. Chandrika, Shruti, any doubt, beta? Shrihit, Kaushik? Do you all understand this? The motion is only one dimensional if the initial velocity and acceleration are parallel or anti-parallel. Do we understand this line?
Yes, sir.
Okay, sir. Then we have equations in the vector form. Remember, whenever we are using equation in the vector form, they are valid in all dimensions 1, 2, or 3. When we are using equation in the scalar form, they're only valid dimension-wise. Yes, Shruti, what is the doubt? Oh, there is no doubt. When we are using the scalar equation, we are treating vectors as scalars. We cannot treat vectors as scalars. Therefore, we will have to use sign convention, my dear friend. Can anyone tell me what is the sign convention, dear? What is the sign convention that we use when we take equation in the scalar form? What sign convention we use, my dear friends? Tell me. What sign convention do we use? I've told you that sign convention before also. These are my axes. This is my plus x. This is my plus y. This is my minus x. And this is my minus y. When we use scalar equation or equation in scalar form for 1D or 2D motion, we only make equation along x-axis or along y-axis. What is the sign convention that we use, my dear friends? Tell me. You know it or not? If anything is moving along positive x-axis, we will treat it as positive. Yes or no?
Yes, sir.
Anything moving along negative x, we will treat it as
Negative.
negative. Any vector along negative x will be treated as negative. Anything directed along positive y will be treated as positive, and anything going down will be treated as negative. Acceleration due to gravity is always downwards. Therefore, we are always going to treat it as negative. Do we understand this?
Negative.
Yes or no?
Yes,
No,
sir.
yes.
Yes, sir.
With those sign conventions into the picture, we have got this equation. Equation number 1, v is equal to u plus at. Remember, this equation is only valid in one dimension motion with constant acceleration. Do we understand this? It is not valid for non-uniform acceleration. Do we get this? Yes or no?
Sir.
V is equal to u plus at. The second equation is, they have written it as S. I will not write it as S. I will write it as delta R. Do we understand the meaning of delta R? If you want to use it at S, you can use it at S, but I've used S for speed. Delta R is my displacement, ut plus half at square. That is equation number 2. Equation number 3 is v square is equal to u square plus 2as. I will not use S here. I will use delta R. Are we getting my point? Yes or no?
Yes, sir.
The fourth equation, you might not have heard about it, but the fourth equation is displacement delta R can be written as v plus u by 2 times t. How do you get this? I will let you know, but first write this. Delta R can be written as v plus u by 2 into t. Then we have the last equation, and that is displacement in the nth second. Have you seen this equation, yes or no? U plus a by 2 into 2n minus 1. We have seen this equation, yes or no, everyone?
Yes, sir.
Similarly, we have equations in the vector form. The only difference is, in the vector form, every equation is written in vector wise. V vector is u plus at. Delta R, do not write it as S. I always use delta R for displacement vector, delta R vector. Then the third one is v square is equal to v dot v minus u dot u. That is how the equation is written. Will be equal to 2 times a dot delta R vector. I always use delta R vector for displacement, and therefore my equation look like this. Do we understand this? Yes or no? No, yes. Please raise your hands, everyone, that we understand this equation. We know these equations. Anjali, Chandrika, Kaushik. The only equation which you probably would not have heard about, but first you write the other equation. The only equation which you probably would not have heard about is probably this equation. I'll tell you how this equation comes. But first note down the rest of the equations, and then I will tell you how this equation has come. Give you 1 minute. Once you are done, please let me know so that I can start. Everyone has written the equations? Yes or no? Okay. The only equation probably which you have not heard is this one, delta R. I'm writing in the scalar form is V plus U divided by 2 times T. Now, how this equation comes, I'll just give you a brief thing. We know that average velocity, I'm not writing the vector equations, average velocity is total displacement divided by total time. Yes or no? We know this one. This is the definition of average velocity. Yes or no? We know this equation, my dear friends. Average velocity is total displacement divided by total time. Do we know this equation?
Yes, sir.
Then from this equation, bacha, I can write the displacement delta R. I am not writing it as vector. Is average velocity multiplied by time. Yes or no? No, yes.
Yes, sir.
Now, in the case of motion with uniform velocity, and please mark the word uniform velocity. In case of motion with uniform velocity, what happens, bacha? This average velocity, we can easily prove it. I'm not going to do that because we don't have time for that. This average velocity becomes the arithmetic mean of maths. So this average velocity becomes v plus u by 2, and that is a very brilliant equation. Find out the final velocity, find out the initial velocity divided by 2. That is your average velocity. But this is only valid when the equation is with uniform acceleration. Do we understand this?
Yes, sir.
Therefore, I have this formula. It comes like this. My displacement delta R becomes V plus U by 2 multiplied by time, and this formula gives us very quick results in some very particular cases. For example, in motion under gravity, it gives us very nice answers, very quick answers. Anyways, you must be accustomed with all the equations that are there. Once you know all these equations, you should be able to attempt any question that can come. Do we understand this? Yes or no? The equations of motion in case of uniform acceleration. Can I now give you some questions on this? Yes or no? No, yes. Are we ready for questions? Can we solve questions, bacha? Everyone is ready? I'm not getting yes from everyone has noted this down, bacha. Please raise your hands and let me know that we are done. Remember, these are questions strictly on uniform acceleration. And here comes the first question based on uniform acceleration. And I hope that you can solve this. Here it comes. Question on uniform acceleration. And I hope that you can solve it. A particle moving rectilinearly. That means in a straight line. I hope you can see this, bacha. Yes or no? A particle moving rectilinearly with constant acceleration is constant, is having initial velocity of 10 meter per second. You can call it plus 10, assuming that it is moving in the plus x direction. After some time, that velocity becomes 30 meter per second. Find out the velocity of the particle at the midpoint of its path. Midpoint. Remember, this is how questions are raised. Questions are framed. You must understand that you only have three equations. V is equal to U plus AT, number 1. S is equal to, or delta R is equal to UT plus half AT square. V square is equal to U square plus 2 times A into delta R or S, whatever you call it. With these three equations, you should be able to solve any question that comes for constant acceleration. And one equation that I've given for you, displacement is V plus U by 2 divided by T. When you know time, that is the equation that you use. I hope you should be able to solve this problem. I'll give you 2 minutes. Please solve it. Yes, bacha, which equation are you going to use here? Remember, the answer to every question is hidden in the question itself. First hint is constant acceleration. Second hint is initial velocity is given. Final velocity is given. So initial and final velocities are given. Now, which equation you can use initial and final velocities? Equation number 1, V is equal to U plus AT. From there, you can get A and T. You don't need A and T, it's not asked. Then S is equal to UT plus half AT square. There is no final velocity, we can't use that equation. So the only option that is left for us, which has initial velocity, final velocity, and velocity at the midpoint of the path. So we are talking about displacements. Initial velocity, final velocity, and displacement. Only one equation has initial velocity, final velocity, and displacement. And which is that equation? Tell me. Which is that equation that has initial velocity, final velocity, and displacement? Which is that equation? Tell me. Which is that equation which has initial velocity, final velocity, and displacement? Tell me. Is anyone there, bacha? Can you all see me? Which is the equation that has displacement, initial velocity and final velocity? Which is that equation? Yes, Bacha, tell me.
U square minus U square equal to 2AS.
Yes, that is the equation that has all the three components. V square is equal to U square plus 2 times A into delta R or S. So that is the equation we must use. V square is equal to U square plus 2 times A into delta R. Yes or no? Do we understand this? Do we understand this? Do we understand this? Please raise your hands and let me know that we understand this, that we have to use this equation. Anjali, Chandrika, Shrihit, Shruti. Do we understand this, beta? So now, I put the final velocity at 30. So that is 30 square would be equal to initial velocity is given as how much? 10? 10 square plus 2, I don't know. 2 is 2. Acceleration, I don't know. So I'll write it as A. Delta R, the displacement. Let me call the displacement as X in this case. I've written displacement as X. That is my equation number 1. This is the equation which I have formed from the data given in the question. Now I look ahead and see what I am supposed to find out. I am supposed to find out the velocity at the midpoint. Let me call that velocity as V. So I make the second equation, the green equation. The final velocity is V square is equal to, the initial velocity is still 10. So 10 square plus 2 times. It is a question of constant acceleration. So the acceleration is A only. The acceleration is A only. Do we understand this? Yes or no? Now the displacement is the midpoint of the path. So total displacement was taken as X. Now I can write this as X by 2. That is equation number 2. Now there are 2 equations and you will see, sir, there are 3 unknowns here. The first unknown is V, the second unknown is A, and the third unknown is X. You will say, sir, I cannot solve this. No, you can still solve this for the value of V, because what you can do is, from equation number 1, you can find out the value of A into X or 2 times A into X, depending on what you are looking at. And then you can put that value from equation number 1 in equation number 2. Do we understand this? And you can solve this. For example, I can put, if I look at this equation, equation number 2, I can cut this 2. From equation number 1, I can find out, I can write like this. Let me use the same blue pen. 30 square minus 10 square by 2 will be equal to A multiplied by X. Now I can put this value of A into X in this equation. So my equation will look like this, the green equation, V square will be equal to 10 square plus 30 minus 10, 30 square minus 10 square by 2. Solving this equation, which is not very tough, you should be able to get the value of v square. Yes or no? Do we understand this? Can I have raised hands from everyone in the class that we understand this, sir? Shruti, Anjali, Chandrika, Shreet, how many of you were able to do this? It's very simple. Looking at what is given to us, looking at what we are supposed to find out, my dear friends, it's easy to understand which equation we should use and which equation there is of no use. Yes, Shreet, you can multiply equation number 2 by 2 and then also get the same answer. Remember, bacha, as soon as you get this equation and this equation, the part of physics is over, my dear friends. Now you have to solve it by maths. And you can use any method that you feel comfortable with. You must be able to solve linear equation in 2 dimensions. I mean, linear equation in 2 variables. And I'm sure that you can solve linear equation in 2 variables. Yes or no? This is a simple case of linear equation in 2 variables, which you can easily solve. I hope everyone was able to do this. Yes or no? No, yes. Can I give you one more question? Again, based on uniform acceleration, that is the topic for the day. Uniform acceleration. That might be the simplest topic because acceleration is constant, my dear friends. We move on to the next question. Everyone has noted down this question? Yes or no? Please raise your hands one last time. Well done. That takes us to the next question. Question number 2, based on uniform acceleration. I think this is from your module as well. Mr. Sharma brakes his car with constant acceleration. Some people call it deceleration, but there is no term as deceleration. It is only acceleration. Mr. Sharma brakes his car with constant acceleration from a velocity of 25 meter per second. That is the initial velocity. To 15 meter per second, that is the final velocity over a distance, assuming that is moving in a straight line of 100 meters. How much time elapses during the interval? That is the first question. You need to tell me the time. What is the acceleration? That is the second question. If he has to continue braking with the same constant acceleration, how much longer would it take for him to stop? And how much additional distance would he cover in stopping? That is the question for you, my dear friends. And I give you 2 minutes. Remember, there are only 3 equations, 4 equations. Depending on what is given to you, you choose the best one. Remember, using only any 2 of these equations, you should be able to solve any question that comes. But depending on what data is given to you, you can choose the best equation, the equation that gives you the answer in the least possible time. And I think Anjali has got the answer also. Anjali, is that so? No. Anyways, I know that you are going to get the answer, my dear friends. Best of luck. I'll give you 2 minutes, more than enough time to solve this particular question. If you can remember the equations, and I've given you some very wonderful equations, can use them, you will get the answer in a flash. 2 minutes is what you get, my dear friends. Yes, my dear friends. Bacho, any answers from anyone? How much time? What is the acceleration? Simple questions. Initial velocity is given, my dear friends. Tan, tan, tan. Final velocity is given, my dear friends. Displacement is given, my dear friends. They're asking you the time. Initial velocity, final velocity, constant acceleration, displacement, and time. Choose the perfect equation. Get your answers. Anyone with an answer for time? Once you get time, everything becomes pretty simple. Yes, my dear friends. Yes or no? No or yes? Shall I do it for you? I'll do fun part and I leave the rest of the parts for you to do. Solution. Tell me, hint, which equation should I use? Yes, anyone? Chandrika, Kaushik, Shreet, Anjali. Which equation should I use? Acceleration is constant, initial velocity is given, final velocity is given, displacement is given, and I'm supposed to find out the time. Which equation should I use? Yes, my dear friends, which equation should I use? No one? That's not good. Okay, Shruti, you can leave. Which equation should I use? And the answer is very simple. Displacement is equal to V plus U divided by 2 multiplied by T. This is the equation that I use. Displacement is given as plus 200 with sign convention. Initial velocity is 25 plus 25 plus final velocity is plus 15. He is still moving in the same direction. Divided by 2. That will give me the average velocity multiplied by t. We can easily find out t from this equation, my dear friends. And equation gives us the value of t as 10 seconds. Do we understand this? Yes or no? No or yes? Anjali, Chandrika, Kaushik, Shri, do we understand this? Yes or no?
Yes, sir.
Everyone understands this? Well, I have found out the value of t. Once you get the value of t, the next question asks you to find out the acceleration. You know the initial velocity, you know the final velocity, you know the time. V is equal to u plus at. You can find out the acceleration. Once you get the acceleration, you can easily solve part number C, which asks you if he continues to brake, how much extra time he will need to stop and how much extra distance will he cover. There are many ways to do this. I leave it to you as homework, the rest of the parts for you to try at home. Can you do this for me? Rest of the parts, please raise your hands, everyone. Only Anjali will do it. What about the others? Everyone will try them at home, yes or no? So, On that note, I will wind off today's class. In today's class, we have seen some really beautiful problems based on uniform acceleration, non-uniform acceleration. We'll continue with motion under gravity, which is again a case of uniform acceleration, and try to wind up uniform acceleration and non-uniform acceleration by the next class. Then the only thing that will be left would be graphs, which we'll cover in the class after that. So I think by Saturday, we should be winding up your motion in 1 dimension, and we will move on to motion in 2 dimension. Remember, even though the name of this chapter is motion in 1 dimension, we have covered question of 1D, 2D, 3D, uniform, non-uniform. Yes or no? Last time, a big raise of hands that I understand that we have done questions not only of 1D but also of 2D, 3D, and we have done some very difficult questions. We have calculated what should I say, distance traveled also from speed. So we have done some really tough questions, and we will continue this journey in the next class. If you have any doubts, please come up to me. Else, this is a wrap from my end. Class ends here. Take care. Have a nice day, and may God bless all of you. Bye bye.